Hello everyone, welcome back to STR8CHEM. In this video, we're going to learn about how to determine the empirical and molecular formulae when you are given a mass composition data set. But before we're going to do that, it's important for us to know what does it mean by empirical formula and molecular formula. Right here, I have given you the definition of empirical formula that says formula that shows the simplest ratio of atoms of different elements present in a molecule. Whereas for molecular formula, the formula that shows the actual number of atoms of different elements present in a molecule. Now, can you spot the difference? Yes. In empirical formula, it emphasizes on the simplest ratio, and we're going to learn on how to determine that afterwards. And in molecular formula, it is emphasizing on the actual number of atoms of the different elements. So when you want to solve a problems, how are we going to solve problems, or how are we going to determine the empirical formula and molecular formula? In this video, we're going to talk about the MAMORA Table approach in solving the problems regarding to the determination of empirical formula. So MAMORA is the mnemonic to remind you, to help you memorize the table that you need to construct in order for you to find out the empirical formula for a given situation. Ma is for the mass in grams. Mo is the moles, mole. And Ra is for the mole ratio. So by constructing the MAMORA mass mole ratio table, you will be able to identify or determine the empirical formula of a given situation. Let's have a look at the first question. So in this problem, we have two species given to you. I'm going to highlight those species, okay? So we have 3.528 grams of iron allowed to react with excess chlorine to produce 10.23 grams of compound. Okay, so that contains only iron and chlorine. So from this question, we know that only two elements will be involved. So we're going to I'm going to write the iron over here, which is the symbol of iron, which is Fe. Okay. And then over here for chlorine, which is Cl. Okay. So this column will be for iron, and this column over here will be for chlorine. From the question, we do know that the mass of iron is 3.528 grams. So I'm just going to go ahead and write it here. 3.528 grams. I do not have to write grams over here because I have the grams right over there already. But if you want to write it down, that should be fine as well. Okay, no problem with that, as long as you're going to have the units with you. So what about chlorine? So what is the mass of chlorine? From the question, we know that when iron and chlorine added together, when iron plus chlorine, okay, the mass of iron and mass of chlorine added together, you'll get 10.237 grams. Therefore, the mass for chlorine would be 10.237 grams minus the mass of iron, okay, which is 3.528 grams. So what is the mass over here, guys? So the mass you should be getting is 6.709 grams. You're just gonna go ahead, right here, 6.709 grams. So your job now is to you want to convert this two masses over here into mole. And how are you going to do that? Remember the MAMORA. Okay? What we can do is, you know that if you want to change mass to mole, you have to divide by molar mass. If you go that direction, you have to times with molar mass. So this is the one that we have talked about in the previous video. So how do we do that? Okay, so we're gonna try to do that by looking at the table that will be given to you in exams. Now we have worked out the masses for iron and chlorine. We're gonna move on to find out the mole. And as what we have talked about just now for the conversion of mole is just like this. It's quite simple. We're going to take 3.528 grams, divide by, if we look at the table here for iron, it is 55.9 iron. Okay, it's 55.9. You're right, 55.9. So the number of moles should be 0.0631 mole. Okay, and for chlorine, we're going to do the same step, 6.709 grams. This is gram per mole. Divide by, if we go back to the table here, chlorine is 35.5. 35.5 gram per mole, then you should be able to get 6.709 divided by 35.5. You will get 0.18896 mole. Now we're going to find the ratio. For the ratio, I'm going to use a different colored pens so that it's easy for you to look at. So between this mole of iron and mole of chlorine, which one is the smallest? Obviously, it's going to be the iron, isn't it? So between these two mole, we're going to take the smallest number of mole and we're going to divide both of them with that. So here we have 0.06, 0.0631 mole. We're going to divide with 0.0631 mole. And you will get 1. Over here, you will get 0.18896 divided by 0.0631. And you should be able to get 2.99, and that can be round off to 3. Okay, so when you look at here, Fe is 1, iron is 1, Cl is 3. So the empirical formula is, you'll get FeCl3. So that is the empirical formula. About the number over here, you can only round it off if you have 2.99 or 1.99 or 2.1 and so on. If you get something like 2.5, 2.7, 2.6, you cannot round that off, okay? So you can only round off something like this. So I'm going to show you, I'm going to try to give you more examples on that. For example, if you have number like 2.99, 3.98, or 1.99, 2.11, 3.12. So if you get number like this number can be rounded off, okay? As long as you have the decimal places in this format, very, very close to the number. But if you have something like this, for example, 3.76, 1.24, 2.5, 3.8, 3.4, these number over here, okay, so these numbers cannot be rounded off. Okay, so you have to be careful. So I'm going to explain later how you're going to solve something that has this kind of number. Okay, so these numbers. Okay, so if we go back to here, so how many marks would you get for this kind of question in exams? You get 1 mark for this part. You have 1 mark for this calculation. Okay, you must show how you get that alongside with the number, and you'll get 1 mark for this, and of course you're going to get 1 mark for the FECL3. Now let's move on to the next one. Problem number 2. What about if the question gives you in terms of percentage? Here it says 47.25% of copper and 52.75% of chlorine. How are we going to do that? If they give you 100% in the percentage form, what you need to do first is you are going to be writing this statement. It's a very important statement. You can write, right here, assume 100 grams equals to 100%. By writing this statement, you would get 1 mark. Okay? This is only applicable if the question gives you in terms of percentage for the mass. So we're going to assume that the percentage over here is equivalent to the grams. Therefore, you have copper, which is Cu. Okay, I'm going to have copper here. And you have chlorine, Cl. So the mass for copper is 47.25 grams because we have assumed that already right here. And the mass for chlorine is 52.75 grams. So what do we need to do next? We're going to change that mass into moles. So we go back to here. I'm going to look for copper. So where is that copper? Copper is right over here. So it is 63.6, as you can see there, 63.6. So you're going to take 47.25 grams, divide by, have a look again, 63.6, 63.6 gram per mole. And that is, how much is that? So we're going to 47.25 divide by 63.6. We get 0.74. Let me double check. 47.25 divide 63.6. You get 0.742. Okay, 7429 mole. And same goes to here. This one is 52.75 grams. Divide by, if you go back to your table, chlorine is 35.5. Then you get 35.5 gram per mole. And what is the mole for that? We have 52.75 divide by 35.5 gram per mole. Then you get 1.485, 1.4859 mole. Okay, so between those two, if you look at those two, which one is going to be the lowest number possible? It is 0.74, isn't it? Okay, so this is going to be smaller than the number of mole over there. Then we're going to use this number, mole right here, to divide both of them to get the ratio. Okay, use a different colored pen. So you have 0.7429 divide by 0.7429. You get 1. 1.4859 divide by 0.7429. Then you'll get 1.4859 divided by 0.7429. You get 2. Okay, so you have 2 right here. Therefore, the empirical formula is CuCl2. And you get 1 mark for this, 1 mark for mole, 1 mark for the ratio, and 1 mark for the empirical formula. Don't forget that if the question gives you in terms of percentage, you have to write assume 100 gram equals to 100%, then you will get 1 mark before you're going to do this step here. Okay, let's have a look at the third one. Now we have 3 columns. The reason why we have 3 columns is because we are having 3 species: carbon, hydrogen, and oxygen. So I'm just going to write that right away inside your MAMORA table. We have carbon, we have hydrogen, we have oxygen. And again, because the question uses percentage right there, it's important for you to write assume 100 grams equals to 100%. Okay, then for this one, you'll get 1 mark already just by writing that assumption. Therefore, the mass would be for carbon is 40. For hydrogen is 6.6. For oxygen is 53.3 grams. And for this question, The question expects you to use the relative atomic mass given to you. So you don't have to refer to your table right here. You can just use those information right away. So to use that information, we're gonna try to 40.0 grams divide by carbon is 12. So 12 gram per mole, and that is 40 divided by 12 is 40 divided by 12. 3.33. So you get 3.333 mole for this. And for hydrogen, we have 6.6 gram divided by 1.0 gram per mole. Then you get 6.6 mole. For oxygen, we have 53.3 grams divided by 16 gram per mole. Then this one is 53.3 divided by 16. 3.3 divided by 16. We get 3.331 mole. So for the ratio, we're going to take the smallest number. We have 3.33. We have 6.6, and we have 3.331. So the smallest over here is oxygen. Well, it's kind of the same as carbon, but you can pick either one of those. That should be okay. So I'm going to take oxygens over here, 3.331. I'm going to take that. Here you have 3.333 divided by 3.331. This one should be 1. 6.6 divided by 3.331. This one should be 2. Okay. You get about 1.98, but you can round it off to 2 because it's 0.98. Remember, if you have 1.9, you can round it off to the nearest number. Okay, here you have 3.331 divided by 3.331. Obviously, you will get 1. So the empirical formula would be CH2O, because you have 1 carbon, 2 hydrogen, 1 oxygen. So that is the empirical formula. So we can take this one mark. You have 1 mark for that line, 1 mark right over here, and 1 mark right over there. But for this particular problem, we're not done yet. Why? Because when you read the question carefully, it says, what is the molecular formula? So how are you going to do that? How are you going to find the molecular formula? To find the molecular formula, we have to look at, okay, to get the, I'm going to write it right here. Okay, so to find the molecular formula, we're going to use the empirical formula that you have. And how are we going to do that? So we're going to compare with the relative molecular mass given to you, which is 108. So we have that 180, not 108. So we have 180, okay, equivalent to your CH2O, and then you have the number N. Now, when you have 180 equals to, we know that carbon is 12 plus hydrogen is 1. You have 2 times 1 and then plus 16, and therefore 108. That is about 12 plus 2 plus 16. We have 30. Okay, so that is 30, and N will be 180 divided by 30. So N is equals to, divided by 30, you get 6. So the molecular formula is CH2O. Sorry, gonna fix that. CH2O to the power of 6. Then the answer is C6H12O6. So that is the answer right over here. So how many marks will you be getting for this? You will be getting 1 mark for this part, 1 mark for getting the value of N, and 1 mark for writing the molecular formula. So that's how you're going to find the empirical and molecular formulae from mass composition data.